Hello, a very good afternoon everyone. Welcome back once again for day 16, that's 29th of April 2025. And I hope you all are ready to attend this bridge course session on vectors, because we have already discussed a lot of things about vectors, if you can recall, isn't it? So today we are going to be discussing about certain things which are as follows. First of all, we are going to be knowing about subtraction of vectors. Subsequently, we are going to be knowing some properties of addition and subtraction of vectors. And in the end, we are going to be discussing about resolution of vectors. So I hope you all are ready. So I hope I am audible to everyone. So if yes, let's get started with a thumbs up over there. Hello, hello, hello. Okay, great. So are we ready, everyone? So let's try to understand subtraction of vectors. Yeah, good evening, good afternoon. Okay, fine. So welcome to day 16. Today we are going to be discussing about subtraction of vectors. So now everyone knows addition of two vectors, isn't it? So today we are going to be performing subtraction of those two vectors itself. If you can recall, we are having a vector which I demonstrated with yellow in color, followed by B vector which I represented in green color. Now I need to subtract them. What if I tell you that there is nothing known to be a subtraction of vectors which exist? Will you believe me? Akshat, it is going to be done in the upcoming context. It's there in today's class itself, polygon law. So if I say you that subtraction of vectors do not exist, will you believe me? Yes or no? It's just the name, nothing else. Okay, someone saying yes. I want everyone to say whether it's yes or no. Do you believe that if I say that there's nothing known to be a subtraction of vectors, will you believe me or not? Okay, fine. So yes, actually there is nothing known to be a subtraction vectors. Why is it so? Because if you can recall about something which I mentioned about negative vectors, isn't it? Negative vectors, yaad hai? Can recall negative vectors, everyone? Yes, so that's what it means. Actually, there is nothing known to be a subtraction of vectors, because we are adding A with, let's say we are trying to perform this operation, everyone. What is subtraction of vectors? It's going to be represented by the equation A vector minus of B vector. But what is it actually? The physical significance of it is going to be A vector plus minus of B vector. Can I write it down like this? Those who are comfortable with this statement, they can give a thumbs up. Hello everyone. Can I write it down like this, yes or no? What is minus B over here? Minus B over here is nothing but, you can write it down over here, this minus B term denotes the negative vector of B vector. Okay? So it's nothing but the negative vector of B vector, isn't it? That's what we can say. I hope it's clear to everyone. So now let's try to perform A plus B. If you can recall the diagram which I drew in the previous class, isn't it? So it was somewhere like this, isn't it? I am just trying to perform A plus B. What I did is, I drew A like this. And by parallelogram law, I would like to prove this, okay? By parallelogram law of addition of two vectors, I would like to prove the subtraction of two vectors, but actually it's just the name, it's nothing like that, okay? We are adding A vector with the negative vector of B vector, okay? So now what I will be doing is, you can recall that I joined the two tails, isn't it? This was B vector itself. And we know that the angle in between those two vectors were theta. And the resultant, we got it as C or R, which emerged from the tails of two vectors at a point where both of them intersected, isn't it? So now what I will be doing is, I would like to follow this operation which I have scribbled it in the upper section of this blackboard. So I will be drawing minus of B vector like this. Can I draw minus B vector like this, everyone? Those who can understand this, they can give a thumbs up. Can I draw minus B like this? If yes, give me a thumbs up. Minus of B vector I am trying to draw. Minus B vector is the negative vector of B vector, isn't it? So now what I will be doing is, you know, this angle is theta. You know that what is going to be this angle? Can anyone tell me what is the value of the angle which I have labeled with orange color? Can you write it down over there in the chat box? Can anyone tell me what's going to be the value of the angle? Let's see. 180. Very good. Pi radians or 180 degrees. Very good. So now what is going to be this? Can anyone tell me what's going to be the value of this angle, everyone? So this angle is going to be, write it down over there in the chat box. The green labeled part is going to be equivalent to, what do you think it's going to be? 180 minus theta. Very good. So this is going to be 180 degree minus theta. You can also write it down it as pi minus theta. Pi is in radians and everyone knows that pi radians is the conversion of degree 180 degrees into the radian format, isn't it? So now what needs to be done? We are going to be using that formula itself of addition of two vectors. What was the formula? So you know that, and obviously the resultant this time, the new resultant which you can expect is going to be emerging like this. So the new resultant, I can say that this is going to be the new resultant, r dash, let's say. Okay. So now we need to write down the value of r dash. So I can write down that the magnitude of r dash is going to be square root of, what we can write it down. Now the angle is just getting changed. The magnitude of a square minus b whole square is going to be b square itself, isn't it? You know that the magnitude of the negative vector of b is going to be having the same value, same magnitude itself. We already discussed about the magnitudes. Plus 2ab cosine of 180 degrees minus of theta. Those who think that we can write down this equation, give me a thumbs up. Those who can think that we can write down this equation, which I have written it over there to the rightmost section of this blackboard, they can give me a thumbs up. So we can write it down like this, yes or no? Sab koi bolo bhai, everyone needs to participate over here, isn't it? Okay, so now what do you think will be the value of cos of 180 minus of theta? Who will say? What do you think will be the value of cosine of 180 minus theta? Can anyone tell me the value of it? Minus of b square, it's the magnitude which we are writing, isn't it? So now what do you think it's going to be the value? So we can write it down over here as, now you see the property is very interesting. Trigonometry, I think so it's already being done in a mathematics bridge course curriculum, isn't it? Correct, Mridula? Yes. So you know that which formula are we supposed to use? You know that cosine of a minus of b becomes equivalent to cosine of a, cosine of b plus sine of a multiplied by sine of b. I hope everyone knows this identity. Those who know this identity, they can give a thumbs up, and everyone knows that the value of cosine of 180 degrees is going to be equivalent to minus of 1, isn't it? So now what we are going to do? Yes, I think so they know that. This equation, this formula, sabko pata hai? Okay, theek hai, pata hai. So now you just need to expand it. You will be able to find out, if I just try to expand this cosine of 180 minus of theta, so I will be able to find out this to be as cosine of 180 into cosine of theta plus sine of 180 degrees multiplied by sine of theta, isn't it? So what is sine of 180 degrees? Sine of 180 degrees is 0, isn't it? And what is the value of cosine of 180? Write it down over there in the chat box. Write it down over there in the chat box, everyone. What is the value of cosine of 180? Write it down, and yes, keep on hitting the like button, everyone. Minus 1. Very good. So this is going to be 0. Cosine of 180 is, cosine of 180 degrees is going to be equivalent to minus of 1. So I will be getting over here as minus of cosine of theta. We are going to be getting as the answer after the expansion of this trigonometric function. So now let's come back over here. So our calculation becomes the modulus of the new resultant is going to be equivalent to what? That is going to be a square plus b square minus of 2ab cosine of theta. So this is what your subtraction of two vectors is all about. Nothing else. We are adding one vector a with the negative vector of the other, isn't it? I hope this equation is clear. So I can write it down over here as r modulus is going to be equivalent to, you can write down this formula, a square plus b square minus of 2ab cosine of theta. Okay, so this is going to be the value of r dash. So once again you can consider this 100 star worth. Okay, everyone can consider this to be 100 star worth equation. Okay, so those who understood this, they can give a like button, and it's an obvious thing, you have to keep on pressing the like button itself. Okay, and give me a thumbs up over here. College will open after 10th. Okay, great. So now this is what the difference is over there. If you can see that while we were adding two vectors, we're having a minus b is going to be equivalent to a square plus b square plus 2ab cos theta. Over here we are having a square plus b square minus of 2ab cosine of theta. That's the only difference in between these two, nothing else apart from it. Okay, so now let's try to understand certain more things actually over here. So the most important thing is going to be, if I want to find out the angle in between the resultant and a vector. Okay, so the only thing which will change is, so I will write it down the expression, you can calculate it over there. So alpha is going to be equivalent to, if you can recall, it was b sine theta, isn't it, to that of a plus b cos theta. In the case of addition of two vectors, it is going to be minus associated over here. So it is going to be, alpha is going to be equal to tan inverse of b sine theta to that of a minus of b cos theta. So this is going to be the angle in between the resultant and the a vector. Okay, and you can also just try to find out the value of in between the resultant and the b vector. It's in Madhapur, Ashwarya. I mean Madhapur, Ashwarya. Okay. So now let's try to know about certain more things. So let's see if you have understood this concept. So let's try to boggle our mind into a problem which is going to be based upon this. Okay, so that's going to be the next question for you. This is the question in front of you. If you're able to see that two forces each numerically equal to 10 dynes, okay, are acting as shown in the figure, find the resultant of these two vectors. Can you write down the answer? You can take the perpendicular bisector, Tamanna, and then you can think about proving it. Okay, that's how we need to prove. Okay, so what do you think will be the answer to this? 10 newtons. Okay, I think so. Sai Satvik is correct. It's going to be 10 newtons itself. That's really great that you are getting the same answer. Yes, 10 newtons. Sai Satvik. Anyone else? 20. No, 10 newtons. Sanjana is correct. 10 newtons itself will be the answer to this question. How to do so? Now if you are able to see that, if I see this thing, 10 dynes actually, the answer, you need to express the answer in dynes itself. There is no need to convert it into newtons. It's not newtons, Ashwarya. It's in dynes. Then you need to convert it. That one dyne, you know that if you really want to convert dynes into newtons, you know that 1 newton is going to be equivalent to 10 to the power 5 dynes, isn't it? So you just need to convert that 1 dyne is going to be equivalent to 10 to the power minus 5 newtons. So we will discuss about this thing in units and dimension. It's a part of your bridge course curriculum itself. So you need to convert it later on, but I want the answer in dynes itself. So what needs to be done? We can see that this vector 10 dynes, which has been drawn horizontally, and this 10 dynes arrow is over here. So I can try to draw the another 10 dynes in green color. So now you know that the resultant will be somewhere over here, isn't it? And you know that based upon the concept which we have seen, that if that is going to be theta, this entire thing is going to be 180 degrees minus of theta, isn't it? So that's what we are going to be doing it over here, isn't it? So you know that if I just try to draw the negative vector of it, the actual negative vector, it would have been somewhere like this, isn't it? And this angle would have been theta. This entire angle is going to be 180 degrees minus theta. This is what we have seen, isn't it? So based upon it, we just need to consider the addition of 10 dynes with the negative vector of another 10 dyne, isn't it? So now what we can do is, we can directly say that the resultant is going to be equivalent to square root of 10 square plus 10 square, isn't it? 10 square plus 10 square, then plus 2 into 10 into 10, into cosine of, you can see that it has to be 180 degrees minus of 60, isn't it? Those are in the favor of this equation, they can give a thumbs up, and you can press the like button, isn't it? So based upon it, what we can do is 180 minus 60, is it clear? Isn't it? It has to be 180 minus of 60. Those in the favor of this equation, they can give a thumbs up. Okay, great. So now what we have to do is, you know that 180 minus of 60 is going to be equivalent to 120 degrees. So this equation is going to become 10 square plus 10 square plus 2 into 10 is 200 into cosine of 120 degrees. So now can anyone tell me what is the value of cos of 120? Write down the value of cosine of 180 over there in the chat box. Write it down. I want the answer from you all because I need your participation in this. Cos of 120 minus half. Very good, Akshat. So cos of 120 is going to be minus of half. You know that, you have already studied trigonometry in your bridge course of JEE Main and Advanced Mathematics curriculum, I believe. So cos of 120 degrees, you can say that that is equivalent to minus of half, because this angle lies in the second quadrant, and in the second quadrant cosine functions are going to be negative. So now if I put this value over here, what I will be getting? So that is going to be equivalent to 100 plus 100 plus 200 into minus of half. So this becomes 2 times 100 is 200. So I will be getting it as 100 plus 100 minus of 100. So this 100 gets cancelled out. You will be getting the resultant of it to be as kitna aega? So let's try to do it over here. This is going to be equivalent to root of 100, which is going to be equivalent to 10 dynes. So 10 dynes is going to be the answer to this question. So you can convert it into newtons. So what to do? You need to multiply this with 10 to the power minus 5. So I will be getting it as 10 to the power minus 4 newtons. Do you agree with this? I hope it's going to be 10 to the power minus 4 newtons. Those who are in the favor of 10 to the power minus 4 newtons, they can give a thumbs up over here and press the like button as well. Okay? So now it depends upon the situation what's going to be given the question, but I ask you to find out the answer in the form of dynes. You can perform the conversion back to newtons based upon the situation. Okay? So now comes the very important law. The next rule is going to be polygon law. I think so Akshat was the one to mention me that, sir, polygon law needs to be done, isn't it? So now the next context which we are going to be discussing over here. But before that, let's try to know about some golden points. These are very, very important. You can 10 newtons. Yes, you are right. Thank you very much. It should have been dynes. Thank you. Dynes is there, right? Very good. Good observation. It's dynes. So write it down over there as dynes over here. Let's say this is dynes and this is dynes. Okay. So what is dyne actually? Dyne is the CGS representation of force. You require a CGS unit, right? Centimeter gram second. So you will be knowing about several kinds of units once we start units and dimension. So over there you will be knowing about these things. For example, CGS, FPS, then MKS, SI. So there are 4 types of units, okay, which we are going to be discussing in the chapter named as units and dimension. Means these are system of units. Not types of units, these are system of units. Types of system of units to be more specific. Okay, yes, foot pound second, centimeter gram second, meter kilogram second, and SI system. The one which we follow in India, but in US and UK, FPS system is followed, and in certain places CGS system is followed. Okay. So now you know that, I think so you have seen, especially if you are going to be going through the books like Resnick, Halliday and Walker. It's an Olympiad book affiliated to physics, and if you are going to be solving the questions, the problems will be given in foot pound second. So that's why you should be knowing the conversion of FPS and MKS. So for example, let me try to mention about certain things of today before we go to the next section, which is the golden points. So the things which I am about to say, that I hope that everyone might have heard about NSEP examination. Have you heard about NSEP examination, everyone? Those who have heard about NSEP examination, they can give a thumbs up. National Standard Examination of Physics. College will start after 10th. No, then hear this name, embrace this name. That's being named as NSEP. That's being named as National Standard Examination in Physics. That's the name. So I believe that if you are preparing for JEE Main and Advanced, you should be aiming to crack NSEP as well, because this will be very, very important to appear for before your JEE Main Advanced examination. So there are certain perks of NSEP as well. So the faculties of Sri Chaitanya, we don't just prepare you for JEE Main Advanced, we also guide you for certain prestigious Olympiad examinations like National Standard Examination in Physics, National Standard Examination in Chemistry, then IOQM. Okay, after cracking NSEP, you will be selected, then you will be appearing for Indian Physics Olympiad. And once you crack Indian Physics Olympiad, you will be cracking the examination, and then you can appear for International Physics Olympiad. So in those situations, what happens is STEM questions are being given, paragraph based questions, where you need to find out the value and write the answer, because you must be knowing that JEE Advanced 2024, there were certain questions which were being asked from STEM as well. They will be mentioning that STEM, a paragraph will be given, and fill in the blanks will be given from the paragraph itself, where you need to answer the question based upon the situation. Okay, so now that's why NSEP, everyone should be preparing for NSEP as well. So in that case, if you are, let's say that I believe that you all are having enormous potential within yourself, so I will be saying that you should be going through this examination information once. I believe that you will be developing some interest on these examinations. Okay, and one more thing, once you are appearing for International Physics Olympiad, the questions will be asked in FPS system, so that's why you should be knowing all types of units and the conversions as well. I hope you got it. I hope you got about these. Okay, so now let's start with this. We are going to be initiating with some golden points. So now you can see that the first point, vector addition is cumulative in nature. A plus B is going to be equivalent to B plus A. So this is a cumulative property, we call it as. Similarly, it is associative as well. So if you are having three vectors, let's say A plus B plus C is going to be written as A plus B plus C. So you can see that over here addition is being done and the braces are being given in the prefix of B and the suffix of C. Over here the braces are being given in the prefix of A and the suffix of B. So now you can, these are very, very important points. You can write down the results. These are very, very important actually. So that's why I came through this important points in this PPT. So now you can see that 10th of May it is. So now what we are going to do is, you can see that R max. So resultant of two vectors will be maximum when they are parallel. That is, the angle between them is 0. You know that. We have seen that thing, isn't it? In the previous class I gave you 3 examples with 3 angles, 0, 180 and 90, and you were the one to tell the answer to the question, if you can recall. So in that case, in between those two forces, if you can recall, 4 and 3 newtons, isn't it? We got the maximum value in the case when the angle in between them proved out to be 0 degrees, and R max, you can write it down it as A plus B. This is going to be the expression. So you can also write down this as square root of A plus B whole square, isn't it? You know, because this is going to become A square plus B square 2AB, and you know that the expansion, this is an expansion of A plus B whole square, isn't it? So now the next case is going to be A plus B, or A plus B max can also be written as mod A plus mod B. This is also, you can write it down. The same thing, let me tell you, the same thing you will be studying in complex numbers. Right now in the upcoming days, in the context of JEE Main Advanced Mathematics, you are going to be coming across this expression once. Okay, so now you can write down, and the next thing is resultant of the two vectors will be minimum. You can write down this when they are anti-parallel, means the angle in between them when it's going to be equivalent to 180 degrees. Okay, So you can see that thing, R minimum is going to be equivalent to A mod of A plus B itself they have given. Okay, so I already said why they are using this A plus B. A few minutes back itself we discussed that it's nothing known as subtraction of vectors which happens, it's nothing but addition of one vector with the anti-parallel, means the negative vector of the other one, isn't it? So now what's being given, so A plus B, so this angle will be cosine of 180 degrees, isn't it? We are just trying to add A vector with the negative version of the other vector, isn't it? So that's why it's being given as cosine of 180. It's going to be square root of A minus of B whole square, and you know that it can be written as, this can be written as what, everyone? So you can write it down it as A square plus B square minus of 2AB, isn't it? Under square root. So that's what they wrote it down over here for this particular thing. So these are the properties, and once again R minimum is going to be equivalent to this expression, and you can write it down, that is, this is minus actually, everyone. This is going to be mod A vector minus of mod of B vector, isn't it? So this is what I'm just trying to say. And now the next thing, which I hope it's clear, everyone, if yes, give a thumbs up. Anything you want to ask? I hope this could be easily visualized when the resultant of the two vectors are maximum and minimum, because the same things are going to be repeated throughout the physics curriculum, especially in wave mechanics. These are going to be there, and wave optics, where maximum value of intensity and the minimum value of intensity will be asked to be calculated. Okay, it's 10th of May, everyone. After 10th of May, you will be having, I think so, your regular classes in your respective Sri Chaitanya centers. Okay, Lakshmikant Reddy. So now let's try to move to the next thing. So this is over here, you are able to see that one more important aspect, resultant of two vectors of unequal magnitude can never be zero. So you can write down these statements are very, very important. Now you must be thinking that, sir, why you are giving these statements? There is something known as the assertion and reasoning. आपने सुना है सबने assertion and reasoning statements which are asked in JEE main examination. Statement 1, statement 2 they will give you, and they will say that which of the statement is correct, and or else they will be asking that whether statement 2 will be a correct preposition for the statement 1 or not. I think so you have heard about, I will write down the type of questions in JEE main which they usually ask. They say that assertion A and R questions they will say. So these are theoretical questions. Once you join our centers, you will be able to see that they are going to be asked in the WTM and QTM examinations. Okay, WTM stands for weekly tests for mains, and QTM stands for quantum tests for mains, where they are going to be including all the previous topics, whatever you are going to be studying, and according to the progress, they will be considering you all, isn't it? So I hope you got this thing. So this is what it's all about. QTM and WTM is all about. So let's say you are being taught two chapters, kinematics 1D, 2D, and suppose you are studying laws of motion, and there is a QTM. Let's say after QTM you will be asked to appear for QTA as well, quantum test advanced examination. So they will be asking you the questions of the entire things, whatever has been taught so far, till that point of time when you are going to be appearing for the examination. Okay, I hope it's clear about this QTM. And WTM over there stands for the weekly test mains, where let's say you will be just asked to appear for a confined syllabus. Okay, so this is the difference in between these two. I hope it's clear. So now assertion reasoning, these are JEE main based questions, JM questions I will say, and you can see that resultant of two vectors of unequal magnitude can never be zero. So you can write it down over there in the notebook which you are using right now while watching my lecture at this point of time. Okay, and if two vectors of unequal magnitude, then minimum 3 coplanar vectors are required for zero resultant. We have already discussed about coplanar vectors, isn't it? Those vectors which lie in the same plane, isn't it? So the same thing is being done. Resultant of two vectors of equal magnitude will be at their bisector. So this things you are able to find out. If A is equals to B, then the angle, whatever might be the angle, it will be splitted half. Theta by 2 it's going to become. And when, if mod of A is greater than mod of B, and then the angle of beta is greater than alpha, means what is beta? Beta is the angle which the resultant makes with respect to this B vector, and alpha is the angle which A vector makes with the resultant. So this is going to be the condition. R will incline more towards a vector of bigger magnitude. Okay, so R is, see, you are able to see that A vector was being given, right, to be greater than the B vector. So this R vector is inclining more towards the A vector, because A vector was having the highest magnitude as comparative to the B vector. Okay, I hope it's clear. Okay, give me a thumbs up over there if it's clear, everyone, and don't forget to hit the like button. Keep on hitting the like button, everyone. So now let's try to proceed to the next slide of ours. Okay, now you can see that if two vectors have equal magnitudes A and B, it's being given, and angle between them is theta. Okay, that's what it's being given as theta. Let's say these are two vectors, everyone. Okay, A and B, and the angle you are able to see, this is theta. Okay, then the resultant will be along the bisector of A and B, which we have already seen. And what is going to be the value? 2a cosine of theta. So now let's try to find it out, this thing. Let's try to prove this thing. What they are trying to say is, okay, let's try to see this, what they are trying to say. Mod of A is being given as mod of B, let's say, is going to be equivalent to A. This is what they have given, small a. Okay, same concept you have to use in wave mechanics, in sound waves, while knowing about intensity, and the same thing is going to be repeated in the context of wave optics, which is a part of your class 12th JEE in advanced curriculum. Okay, so now let's try to see what's happening everywhere. So now we can say that if they are equal, I can say that the resultant is going to be what? We can add these two vectors, and let's say the angle in between them is being given as theta, just like the way they have given over there. So what I will be saying, a square plus 2a square cosine of theta, isn't it? That's what I can get it, everyone. So based upon this, we can write it down it as, what I will be getting, 2a square plus 2a square cosine of theta, isn't it? So let's try to take this 2a square outside. It's going to be 1 plus cosine of theta. I hope it's clear, everyone. So now what needs to be done in the upcoming context? So now I hope it's clear, everyone. This a square plus a square is 2a square, and 2ab is becoming 2a square. Now everyone knows that now we need to express this theta in the form of submultiple angles. So I think so in trigonometry, most of you people have already studied about this submultiple angles. Those who have studied, give a thumbs up. Submultiple angles, multiple angles का concept सबको पता है. The values are being given, isn't it? A is going to be equivalent to, isn't it? Theta is 120. Okay, नहीं. अब देख लीजिए क्या होना चाहिए. So theta by 2 we can say is a submultiple angle. Theta by 2 is nothing. What is theta by 2? Let's try to understand this first. It's nothing but the submultiple angle of theta, isn't it? So now we can write down 1, we can write it down it as cosine square theta by 2 plus sine square theta by 2. We can substitute it for unity like this. Whenever you are able to see these things, especially in integration for your JEE in advanced curriculum and certain trigonometric questions, you can substitute for unity like this. And similarly, cosine of theta, which is nothing but cosine of 2 theta, cos of 2 theta can be written as cos square theta minus sine square theta. I will write it down over here. Cosine of 2 theta can be written as cos square theta. These are new identities which you need to know. I think so in maths they have already been listed in your JEE in advanced curriculum for this bridge course, everyone. Okay, so now based upon this I can write down cosine of theta can be written as cosine square theta by 2 minus of sine square theta by 2. Okay, so this is what we need to put it over here under the square root expression which we are having in order to find out the resultant. So this is going to be equivalent to 2a square. 1 can be written as cos square theta by 2 plus sine square theta by 2, isn't it? And cosine of theta can be written as cos square theta by 2 minus of sine square theta by 2, isn't it? just close the open brackets and extend this line associated with the square root, then what are we supposed to get? This you can see that sine square theta by 2, sine square theta by 2 gets cancelled out, and we are going to be left behind with this expression, which is 2a square, isn't it? It's going to be into 2 times, right? We are having cos square theta by 2 plus cosine square theta by 2. They will be becoming twice, isn't it? So it's going to become twice of cosine square theta by 2 I will be getting. So as a result, it's going to become 4a square cosine square theta by 2, isn't it? So it can be written as the resultant can be taken outside, and I will be getting it as 2a cos of theta by 2. This is what I will be getting, 2a cos of theta by 2. The expression which I wrote it down over there. So that's how you should be knowing the method. I hope it's clear, everyone. So this is what it needs to be done in order to get this. So those who understood this one, they can give a thumbs up and hit the like button as much as they can. Okay. Don't just keep on discussing about yourself. Don't worry, the college will be getting started. Right now, sit back, relax, enjoy this YouTube session of yours, because after a while, you will be missing this session for sure. I'm 100% assured about this. Yes, you can also write down exact Tulsi Krishna, you are right. You can also write it down as cosine of 2 theta, 1 minus 2 sine square theta, or the 2 cosine square theta minus 1. That can also be done. Okay. So 1 we substituted it. This is what I'm trying to do, Anita. Okay. This 1 and cosine of theta we are just trying to substitute, isn't it? This 1 and cosine of theta, this is the substitution of this unity expression, and this is the substitution of cosine of theta expression over here. Okay, that's what we are trying to do in this context. Okay. No, I don't know about CBSE results, everyone. I believe that every one of you are capable of scoring 100%. 100%, I will say. Especially in maths, 100, science, 100. I hope you all are getting 100 out of 100 in science and maths. Are you getting? Those who are getting 100 of 100 in maths and science, they can give a thumbs up. Out of 100 of 100, I'm saying 500 of 500 CBSE boards, I know that. 500 of 500, isn't it? 500 का होता है ना CBSE examination. 600 तो नहीं होता है. Another one is computer science, that's a optional subject, isn't it? Okay, चलो आगे बढ़ते हैं. ठीक है, तो now you can see the special case it's being listed over here. Now let's try to discuss about the special case over here. If theta is going to be equivalent to 120 degrees, then r is equal to 2a cos 120 by 2, you know that, and it's going to be equivalent to a in the end. And if theta is equal to 120 degrees, then r is going to be a plus b, and mod of a is equal to mod of b is equals to a. Okay, so whenever you are having 120 degrees, because this is a very commonly asked JEE main question, ये आपका बहुत ही commonly asked JEE main question है, ठीक है? So tell me at what angle the vectors are going to be equal. Okay, so I am giving you the answer over here itself. You can check it reversely. You will be getting it as when the theta is going to be 180 degrees. Okay, so and the one you can say resultant of 2 unit vectors. Okay, this is also another. These all are very important. See, these are all previously asked JEE main questions. The one which I have made it in the form of note. If they ask you in your, you will be getting these questions for sure once you appear for either of our WTMs or QTMs. Either of these questions, either one of these statements are definitely going to be asked. Okay, resultant of 2 unit vectors is another unit vector, then the angle between them is 120 degrees. You can check that thing. You can check that thing, everyone. Okay, so now let's start the next concept, which is very, very important. Are we ready for this? Resolution of vectors. Once again, this is a very, very important. See, that's why, see, there are several theories. I could have come with n number of things over here, but I am having an indigenous way to be more specific, to teach resolution of vectors. That's my own ingenuity in this context. So are you ready for the resolution of vectors? Because today we are about to complete resolution of vectors, and hold on your hats, because I will say you something very interesting once I complete this resolution of vectors. Because wherever you are able to see velocity vector oblique velocity vector, oblique acceleration vector, oblique electric field vector, oblique magnetic field vector in any of the quadrants, you need to resolve vectors into components, because you can apply Newton's laws of motion along the x and y direction, which forms out to be the basis of solving most of the complicated questions of physics based upon dynamics. And it's going to be helpful everywhere. In most of the chapters, in 90% of chapters, you will be requiring this resolution of vectors. So are we ready for this? So what I am trying to do is, I will try to draw a Cartesian plane. So everyone knows about a Cartesian plane, right? So this is the y-axis, this is the x-axis. This is the negative y-axis, this is the negative x-axis. I hope it's clear. This is how we can try to draw the Cartesian plane, everyone. Okay? Those who are in the favor of this Cartesian plane, they can give a thumbs up. Okay, I will try to draw it once again. I think so we need to be perfect with our drawings, isn't it? So what I will do once again, I would like to draw. So okay, this is y dash, isn't it? Yes or no, everyone? Negative y-axis, x dash. Okay, so now let's say we are having 4 vectors. Everyone knows quadrants, right? So first of all, let me assign the quadrants. This is the first quadrant. We will be calling this as first quadrant, isn't it? In order to understand it better, let's try to name the quadrants. This is second quadrant. This is going to be the third quadrant. This is the fourth quadrant. And now you need to draw vectors. Let's say we are having 4 vectors across 4 quadrants. Okay, so let's try to start like this. We are having 4 vectors in 4 quadrants. Let's say this is the orange vector. I will mark this as A vector. Okay, let's say we are having another vector. Let's say it's B vector over here in green. Let's say we are having another vector. Let's say blue vector being mentioned in the third quadrant. And last but not the least, which color shall I choose? Let's say the red vector. That's C vector, which I have drawn it in the fourth quadrant. Now let's say that these are going to be these vectors. A vector makes some angle of theta with respect to the x-axis. And you can choose the angles. You can use any Greek letter over there to mention the angles. Okay, whatever you're having in your mind, you know the Greek symbols, isn't it? Theta, then alpha, beta, gamma, eta, delta, isn't it? Anything you can say. So now let's say this is theta dash, I will say. Let's say this angle is alpha, this is alpha dash. Let's say this is beta dash. These are the angles, everyone. And let's say this is gamma, gamma dash, and this is gamma. I hope the diagram is clear to everyone. So we are having what we are trying to do. We are drawing the Cartesian plane, and then we are considering 4 vectors over here, A vector, B vector, C vector, D vector, and all these vectors were making some angle. They were oblique in nature. Oblique, everyone knows the term which I am about to write it down over here, that's oblique. So all these vectors were oblique along the x-axis and the y-axis. They were making some angle theta with respect to the x-axis and the y-axis, isn't it? So now we need to resolve these vectors into components. Now let me tell you that while we discuss about addition and subtraction of 2 vectors, I mentioned about resultant, isn't it? Resultant is the sum of the 2 vectors, isn't it? And after that, I use the formula square root of a square plus b square plus 2ab cosine of theta for addition of 2 vectors. And subtraction, we have seen that is nothing known to be a subtraction. We just found out that it's one vector was being added to the negative version of the other vector. Okay. So now if I say that this myself, me Avinav Banerjee, is a vector, let's say, I will be having components. What are the components? My 2 arms and my 2 legs will be acting as a component to this vector. Okay. So in the same way, any vector will be having certain components, certain projections along the x-axis, y-axis and the z-axis. So that's the reason I require the concept of resolution of vectors. Okay, so now since I have drawn a Cartesian plane 2D system, Okay, so I will be trying to resolve these vectors into two components itself. That's it. There can be third component. You will be gradually knowing it. Once you start studying kinematics, you will be gradually knowing about the third axis and the third resolution of the component. Okay, so now what I will say is, now if I try to resolve this A vector, see, it's a very interesting stuff. There are a lot of complicated things available in the books. Okay, whenever you are able to see A vector, you can see that the A vector is lying in the first quadrant, isn't it? So the components will be also along. You can say that. I will just try to draw it with some neutral color over here in order to make us understand it in a better way. So I will say that, okay, this color is not visible. Okay, so what I will do is, okay, let's try to do it like this. So you can see that I have drawn the components in such a way that they are going to be the smaller version of the axis of the quadrant where the vector is lying, isn't it? I hope everyone's able to see. X, Y axis, positive X, positive Y, like this. So this is going to be known as the X component, and this is going to be known as the Y component. The same thing we can do it for all the four vectors, isn't it? Like this you can do, like this you can do, isn't it? Like this you can do for the D vector, which I have mentioned in red. Actually this is D vector, everyone. So mark this thing, this is D vector. I hope it's clear. Everyone, I hope it's clear, just like the way I am just trying to draw the X components and the Y components. What are X and Y components over here? They are nothing but the smaller versions of the X and Y axis in the quadrant where they are lying. Okay, like this I have drawn. So now what is going to be the X component or the Y component? Now choosing the value is the most important thing, and you know the sign convention very well. So if this X component, which is for A vector, will be positive, for Y component has to be positive. For this you can say along the negative direction of X axis, if I say, okay, you know that the X component of B vector has to be negative, the Y component of B vector has to be positive. For C vector, we can say that both the X and the Y component has to be negative, because you know that over here along the negative direction of X axis there comes minus of X, and over here it's minus of Y, isn't it? I hope everyone knows this. Everyone knows the sign convention, isn't it? Everyone knows the sign convention of the Cartesian plane. Aata hai na? Isn't it? Yes. So now for the D vector, you can see that the X has to be positive and the Y component has to be negative, isn't it? So now what we have to do is, let's try to solve one after the other. Let's try to analyze this A vector. Let's try to analyze the A vector first. You can see that this was the situation. A vector was being depicted in orange color, isn't it? So let's try to draw this as your A vector. So now what we have to do, let's try to resolve into components, isn't it? It will be the smaller version of the axis of the quadrant where it was existing, isn't it? So now what I will be doing is, 10th of May is the last class, Harsha Reddy, okay? So now let's say the angle which it was making with respect to the x-axis was theta, and this vector was making an angle theta dash with respect to the y-axis, okay? So everyone is able to see this is the x component, isn't it? And this is going to be the y component, okay? I hope everyone's able to see. If you're able to see, give me a thumbs up and press the like button as well. I hope it's clear, everyone. So now what needs to be done is, now this value of x can be written as a cos theta, and you know that it is going to be associated with some unit vector. And we have seen that, we have studied that thing in the previous classes, that any vector which is being directed along the x-axis will be associated with some unit vector of I cap. Similarly, this y component can be written as a sine of theta j cap. Now how it's coming? You must be thinking that, sir, you must be wondering, sir, how am I getting a cos theta I cap, a sine theta j cap directly? Is always the x component is going to be a cos theta, and is always y component is going to be a sine of theta? No, it depends. How? We'll try to analyze this. See this thing, everyone. I will just try to draw a vector over here. You know that the magnitude of a is, what is the magnitude of a vector? A itself, let's try to say that the magnitude of a vector is a. But in the questions you can be given some value based upon it, okay? So now this is your x-axis and you need to draw a perpendicular bisector like this. This is theta. ये value क्या हो जाएगा बताइए? What will be the base? Let's say the base is x. Let's say that the base is ax. ठीक है? Let's say that the base I am marking it as a subscript x and the perpendicular is being given as a subscript y. I hope it's clear. So now we need to find out the values of ax and ay. What we can do? Can I say that from this right angle triangle, cosine of theta is going to be ax by a. So what will be the value of ax? Ax can be written as a cosine of theta, isn't it? And similarly, I can say that sine of theta, you know that it's perpendicular by hypotenuse. Over here, the perpendicular is ay and the hypotenuse is a. So ay can be written as a sine of theta, isn't it? Ay can be written as a sine of theta. Now it's clear. And obviously, you need to write down the unit vectors associated with it. So that's why since it's along the x direction, I am just associating it with I cap. And since it's this one, the y component a sine a of sine theta is along the positive direction of the y-axis. I wrote it down it as a sine of theta. Akshat, I cap, j cap are the unit vectors. I cap is the unit vector along the x-axis. J cap is the unit vector along the y-axis. Okay. So now what needs to be done is, now it's your question is that, can you write down the x and the y component in terms of theta dash? My question, I'm repeating it once again. Can you write down the values of x and y components in terms of theta dash? If yes, write it down over there in the chat box and give me a thumbs up. Everyone? Then write it down, everyone. What do you think? क्या होना चाहिए? X component can be also written as a sine theta dash I cap. Am I correct, everyone? Can I write it down it as a sine theta dash of I cap? Theta dash, I am saying in terms of theta dash. And similarly, you can write down this y component over here as a cos theta dash j cap. Why not, Samarth? See this once again, what I will do. Dhyan dijiye. This is a. Now the angle it's making is with respect to the y-axis, isn't it? Now the angle is with respect to the y-axis, which is theta dash. क्या करना है? Draw the perpendicular bisector. This time, this is going to become, you know that, this is going to be ax and this is going to be equivalent to ay itself. ठीक है? तो क्या होना चाहिए? And this value is x in this right angle triangle, the one which I have drawn. I will try to draw it in a better way. The bigger version I will try to draw in order to make you understand. Everyone needs to understand it. नहीं समझ में आ रहा, I will mention it once again, over and over again, because it's a very important concept. Okay? So now you can see that we are having a vector. इधर बनाते हैं, चलो. Now it's making some angle of theta dash with respect to the y-axis. I hope it's clear. This is the y-axis. Theta dash बना रहा है angle. क्या करना है? You need to draw a perpendicular bisector like this. This has to be equivalent to ay. That will never change. This will be equivalent to what? Ax. Okay? So what will be the value of cosine of theta? You can write down cosine of theta dash is going to be equivalent to what we can say. Now this is the right angle triangle. You know that cosine of theta is base by hypotenuse, isn't it? You can write it down it as ay by a. So in this case, in this aspect, it's going to be equivalent to what I will be saying. Ay can be written as a cos theta dash j cap. And similarly, you can write down sine of theta dash is perpendicular by hypotenuse. Over here, the perpendicular of this right angle triangle is becoming ax, isn't it? So ax by a. So ax can be written as a sine of theta dash and I cap. Now it's clear? Now is it clear, everyone? See this. I hope it's clear, everyone, this time. If yes, if you're able to see that, give me a thumbs up, press the like button. Give a thumbs up, भाई सबको ही बताइए. You need to be observant over here. देख लीजिए. Everything is being mentioned in terms of trigonometry itself. I haven't written any sort of analytic language over here. Everything is being given in the form of trigonometry itself. Okay. So now based upon it, Panduru Manoj, see this thing, AX, AY. There are two angles which are being given. One when the vector makes an angle with respect to the x-axis, and when it makes some angle with respect to the y-axis. Shortcut, this is the rule which they have mentioned in the book. Okay. So now you can see that I am saying that this has to be the x component. I have drawn a perpendicular bisector from the vector itself. You know that the magnitude of this A vector, what is A? You know that A is, you know this thing very well, I have already mentioned in the previous two classes when I started vectors, that you know that mod A is A, isn't it? The magnitude of the vector is A. So I have drawn a perpendicular bisector over here, and you can see that the base is AX, the perpendicular is AY, okay? So now what will be the value of cos theta? Cos theta, you know that AX by A. So I can write down AX as A cos theta I cap. Similarly, you know that sin theta is AY by A. Henceforth, I could have profoundly written the value of sin theta as what? AY by A. So AY will be A sin theta j cap. So now this is the value when we are getting, when the angle is being listed in the form of theta, when the angle of the vector is with respect to the horizontal. We call this situation as horizontal analysis. And this will happen when the angle is with respect to the vertical. So that's why you will be encountering certain situations in the upcoming context of Newton's laws of motion, kinematics, projectile, ठीक है? तो ध्यान रखना, बोला जाएगा angle, velocity is making some angle with respect to the vertical, with respect to the horizontal. So that's why you need to be clear about all these aspects, okay, everyone? So now your homework, so that's why you are going to be getting A sin theta, right? Over there you can see that you can also get in the form of vertical, you will be getting these two components, isn't it? With respect to the vertical, you will be getting A sin theta dash I cap and A cos theta dash j cap, okay? And with respect to the horizontal, I will write it down over here. You are getting this with respect to the vertical. This is with respect to the vertical. And these you are getting with respect to the horizontal. Right? Horizontal. What is horizontal vertical? The angle which the vectors make with respect to the horizontal or the vertical. So now see, so now your homework is to complete this. Then tomorrow I will mention it once again, okay? Tomorrow you need to answer me this. What will be the components of B with respect to horizontal vertical, C with respect to horizontal vertical, D with respect to horizontal vertical. Okay. So that's your homework. And tomorrow I will complete this diagram. Okay. Tomorrow we are going to be completing this diagram. Okay. Got it, everyone? I hope it's clear. And after that, I will mention you something very interesting about this diagram, about this resolution diagram, everyone. Okay. Why do we need I cap, J cap? Rajesh Yadav, go and watch the previous lecture sessions. I already mentioned about base vectors, isn't it? We already discussed about base vectors in the previous class. So, okay. So, what else? Anyone? Tomorrow will continue, to be continued. We'll try to do the resolution of the remaining vectors in the second, third and fourth quadrant, but it's not any sort of restriction that you cannot do it. You can do it as well. Okay, everyone. So now, tomorrow we will continue with resolution of vectors and some questions based upon addition and subtraction of vectors. Okay, everyone. So that's it for today. Thank you very much. So I'm departing right now. So before I depart, once again I would like to say that don't forget to like this lecture session, share this lecture session as much as possible, and keep on clicking the like buttons because that's what it's mandatory. Tomorrow we'll come with some more interesting problems and we'll continue with the context of vector resolution itself. We'll try to resolve the vectors B, C, D which were existing in the second, third and fourth quadrant itself. So, and in the end I would like to say that you can subscribe our Sri Chaitanya Educational Institution YouTube channel. So departing right now, it's Avinav Banerjee for you. Good night, good evening. Meet you tomorrow at 4 p.m. in the same place itself. Thank you very much.